part F. So I'll scroll over to part F here. It has to do with the volume of a solid. So in part F it says, consider the region R enclosed by the graph of our function and the axes. Find the volume of the solid obtained when R is rotated 2 pi about the y-axis. Okay, so I'll get my calculator out. And I've zoomed in here, and this is actually the area they want us to get R, and then we're going to rotate it about the y-axis. So our limits are going to be from 0 up to 1. I've just found that there. So our volume will equal pi between 1 and 0, and it's around the y-axis, so it needs to be x squared dy. Now pi integral of 1 and 0. Now if I wanted to get my function in terms of x, notice that I've almost done some of those steps already. When I found the inverse function, if I just from this step here tried to rearrange and solve for x, I would actually get this answer down here in my box here, but these would be y plus 2 and 2y plus 1. These happen to be x and y because I swapped x and y, finding the inverse. So I know it's a little bit confusing, but if I had just rearranged to solve for x in the original equation, which I pretty much did here with all my inverse steps, this is the function we'd have. So the one we're integrating would be ln, and it's going to be y plus 2 over 2y plus 1, and it's all of this squared dy. Okay, so we can just put all of this into the calculator as a definite integral, and I've done that for us here. So I've put in the definite integral pi between 1 and 0 ln and our whole function squared, and we get a volume of 0.331. So our volume is 0.331. Okay, that's the answer to part F.